Hello everyone, we are going to be presenting on analyzing global CO2 emissions, trends, contributors, and future predictions. We are presenting for the class Visual Analytics and Business Intelligence. And our team members are me, Kripa, Abdueli, and Jerry. Now let's start with the introduction.
Hi, so I'm going to talk about the introduction. So in today's world, CO2 emissions are becoming a more and more serious issue, and carbon dioxide emissions are especially viewed as one of major causes of climate change in the world. Apart from being a prime cause of environmental pollution in the world, they also pose a significant threat to human health and well-being. So it's become an issue that brings major concerns. And the world has a rapid increase in carbon emission throughout the years, rising from 4 billion metric tons in 1940 to 37 billion metric tons in 2021, which is like 6 times higher. So in this project, we plan to analyze the CO2 emission of each country since 1980 and predict the future emission. And the data set contains 213 countries and 5 main fossil fuels, which are coal, oil, gas, cement, and flaring. Okay, so next page. So mainly we have 3 research objectives. They are to find out the countries producing the highest CO2 emissions and to observe which fossil fuel contributed to the highest CO2 emission, and also to predict the CO2 emission by each country. Next page, please. So as for our scope of project, our project will focus mainly on finding a trend in CO2 emission. First is to figure out the highest energy emission by each country, and also the trends of CO2 emission in each country, also predicting the expected emissions in the future. Okay, next page. Yeah, so as for our research gap and the significance of the study, so based on the literature review we did before, it is evident that several studies have investigated the factors contributing to CO2 emission in different countries, but there is a research gap in understanding the complex interaction between the various factors contributing to CO2 emission and how they can be effectively managed to mitigate the issue. Also, the study revealed provide insight into the factors contributing to CO2 emission, and they are mainly focused on identifying the positive and negative influence of CO2 without exploring the interaction. So we will do more work exploring the interaction and trade-off between them. Yeah, so for the significance, for the prediction of CO2 emission, the science study have used different methods like STRIPET and ARDL to predict CO2 emission accurately. But the accuracy of this prediction may vary depending on the data in each country.
No.
And
got disconnected.
We are still recording.
Okay.
It's fine. Yeah. So for the data source and dictionary, we got country, alpha 3, year, total, coal, oil, gas, cement, flaring, other, per capita. So for the country and alpha 3, it's the data type is like string, and for the year is integer, and for all other variable like the factors, they are all float like coal, oil, gas, cement, flaring. Okay, next page. And here we got two hypotheses. The first one is that we assuming that all countries have equal contribution to the total CO2 emission. And the alternative hypothesis of the first one is one or more than one country has a higher contribution to total CO2 emission than the other. And the hypothesis two is all fossil fuels have equal contribution to the total CO2 emissions, and the alternative hypothesis is one or more than one fossil fuel has a higher contribution to the total CO2 emissions than the others.
All right, thank you, Jerry. Now I will talk about the descriptive statistic. So in our data set, we have 232 unique values in the columns countries, which include the global emissions and international transport data as well. So this descriptive statistic provides for a data set related to countries' energies consumption and emission over the years. The data includes just like Jerry described previously, we have year total, coal, oil, gas, cement, flaring, others, and per capita. This this descriptive statistics provide a summary measure for each variables, including minimum, maximum, median, mean, and quartile values. They give an overview of the central tendency, spread, and distribution of the data for each variable in the data sets. Next, this is our visualization. We've done the visualization by Tableau. So in this first figure is related to average annual carbon dioxide emissions from 1980s to 2021. And this chart comprised a bubble chart with countries represented as circles, and the size of the circles indicating the magnitude of their average annual emissions. The larger circles represent countries with the higher emissions. Based on the virtual presentation, as you can see from the slides, it is evident that China and the United States had the highest average annual carbon dioxide emissions, as they are ranked first and second respectively, and the larger cycle representing these countries indicating their greater emissions compared to other countries. Following China and the United States, we have Russia, India, and Japan are ranked third, fourth, and fifth in terms of the annual emissions. Moving on to next figure, it displays a tree map showcasing the top 10 countries with the highest emissions. And from 1980 to 2021, this tree map presents the emission data in the kilotons for the measurements for each country over the specified time period. The emission data for the top 10 countries shown as China, USA, Russia, India, Japan, Germany, United Kingdom, Canada, Ukraine, and France. And this tree map provides a clear overview of the countries with the highest emissions, and they're ranked in the descending orders. It allows for easy comparison of the emission levels among these countries, with China and the USA appearing as the top two emitters, followed by Russia, India, Japan, Germany, United Kingdom, Canada, Ukraine, and France. So in this figure, the emission data provides a quantitative information on the emission level of these countries, which can be valuable for understanding the global distribution of carbon dioxide emission and identifying countries with significant contribution to the overall emissions. Moving on to next figure, we have the average emissions for each fossil fuel from 1981 to 2021 period. To 2004, the oil was the fossil fuel that emitted the most carbon dioxide. After 2004, the coal has become the fossil fuel that emit the most carbon dioxide. As we can see from this chart, except for flaring, all other fossil fuels have shown significant increased trends since 1981. Carbon dioxide emissions are not only related to the speed of the national economic development, but also affected by some global events. For example, due to the COVID-19, many factories has experienced both short or long-term shutdowns, resulting in a 4.9 drop in global carbon dioxide in 2020 compared to 2019. Countries such as UK and the US, France are all saw their emissions fall by more than 10%, with only a few, such as China, seeing an increase in 2020. The last figure presents data on average carbon dioxide emission per capita in keltons from 1980 to 2021 for the top 10 countries with the highest emissions. As you can see from the figure, Qatar consistently had the highest average CO2 emission per capita over the period. And Qatar has maintained this highest average CO2 emissions per capita over the period from 1980 to 2021, indicating the precedence trends of high CO2 emission in that countries. Other countries such as Curaçao and the United Arab Emirates are also relatively high, are also showing the relative high average of CO2 emission per capita. The percent of countries from various regions on the list, including countries from Middle East, the Caribbean, Europe, North America, highlights that the high carbon emissions per capita are not limited to a particular region. But rather a global issue, of course. The data shows that even countries with a relatively smaller population, such as Qatar and Curaçao, can have high average CO2 emission per capita, indicating that the population size is not the sole factor driving the emissions, but also other factors such as industrial activities, energy productions, and transportations. The lower average CO2 emissions per capita in countries like Luxembourg and Canada, for example, compared to top emitters, suggest that there may be a difference in emission intensity, energy policies, or economic structure among countries that influence their emission patterns. Beside those three figures, we also want to show our Tableau dashboard. Oops. So, as you can see from the dashboard, on the top we have the average CO2 emissions world map, and the below one is the average CO2 emissions over time. So, if I click on one country, for Russian, for example, Russian has the during 1980s to 2021, Russian has the significant drop in the emissions during 1990s that could caused by because the Soviet Union country was no more. It becomes a Russian after that period, so that could be one of the reasons that the CO2 emission drops during that time. And you can also see different countries. You can select any countries to see their trends over this specific period of time.
Now let's move on to a modeling. And for our modeling, we decided on 3 different models, machine learning models, that is linear regression, extreme gradient boosting, and random forest. Before we start with the modeling, we had to make sure that our data is clean. And for that, we applied different models. Next page, please. First of all, we did feature selection. Before doing feature selection, we had to make sure that our data was clean. For the cleaning part of our data, we decided to replace the null values with the mean of the null values. We decided to let go of unimportant features such as the ISO alpha. That was just the code for countries, since it is repeated information, so we did not include it in our analysis. And further selection of features and would consist of looking at what kind of features we had and how they were related to the dependent variable, that is the total emissions that is done by each country throughout the years. And our independent variables, as seen in the slide, is oil, per capita, gas, the different countries, coal, cement, flaring, year, and other emissions. So for oil, it is the emissions that is created from oil production, and per capita is the per capita emission, and so on and so forth. And this feature selection, this importance table that you see over here, is done by XGBoost model that we use for the feature selection. And from this model, we can see that the oil is the most important feature, followed by per capita, gas, country, coal, cement, and flaring, whereas year, the year that the data was recorded, and other emissions, that is emissions not including the ones mentioned before, these were not that important. And another trend is that for the other emissions, when we try to use the null values, it has a lot of null values, and when we try to impute the null values with the mean of the values, then the data in the other section was not at all visible because it was replaced by the mean. So we decide from the feature selection that we will not use this part of our data at all. Now moving on to the next slide. So as I said before, for the data cleaning, we replaced the null values with the mean. We selected relevant data, as already seen from the feature selection. We have only selected the data that are important to us. We have removed unimportant data, that is ISO alpha, that is repeated information, as well as the section of other emissions, and also removing outliers. So as you can see from our data in the data descriptive statistics, that our data consists of a lot of range. For the maximum, it is 10,000, and for the minimum, it is 0. So in that section, we have a lot of outliers that we can also see from our processing our data. So before we start with our actual modeling, we decided to remove the outliers. We decided to look at the outliers that we had in our data and then remove the outliers so that we could present a more accurate reading. Next slide, please. Now, after removing all the outliers and cleaning the data, pre-processing the data, we came up with this heat map to find out the correlation between different factors and the total emissions. And as you can see over here from the heat map, most of the fossil fuels are positively related to each other, as well as the total emission. Whereas year, the data when it was recorded is negatively related to oil, negatively correlated to oil, and has little to no correlation to other factors as well as the factor in others. It has little to no correlation, or it has negative correlation to flaring and per capita. So we also assume over here that this column is not at all useful for us for our analysis. Again, for the per capita as well, it has negative correlation with the cement and as well as the other fossil fuel sector. Now moving on to our actual modeling part. From our linear regression, after imputing all of the data, we came up with the linear regression model to see how each of the independent variables were connected with the dependent variables. And for this, after analyzing this, we came out with this table where you can see the intercept and all of the data is below. And from this, we can see that all of the per capita flaring gas, oil, and coal, these are positively related with the total emission, which means that when the per capita, for example, when the per capita emission increased by 1.1, then the total emissions also increases by the multiple of this 1.1. And you can see over here that all of our data, except for flaring, is very significant to our study. And also that cement is negatively related to the total emission, which means that if or when the total emission, when the emission from cement rises, then the total emission actually decreases, which is quite surprising seeing our data. Similarly, we can also see this residual standard error, which is 26.23, which means that our model is pretty good at predicting the data, as well as our multiple R-squared is 0.38, or adjusted R-squared is 0.3794, which determines the accuracy by which it predicts the variables, which is very good as well. The accuracy is also good. And also something else we can see is that the intercept is 3.05512, which means that even if all of the other emissions remain even or remain constant or zero, the intercept is still 3.055, which means that even if there is no other emission, the total emission will still be 3.055 kilotons. Now, as for the next analysis, we used, after the linear regression, we used the gradient boosting method. And from the gradient boosting, we also utilized gradient boosting to see the total important variables in our data set. And from this one, we can see that oil is the most important feature. That means that it is the most important predictor to our to predicting the total emissions, followed by per capita, coal, and gas, whereas cement and flaring were not that important. And for our gradient boost model as well, we calculated the root mean square error, and the root mean square error was 18.12861, which means that our model is pretty accurate at predicting the percentage of, the relationship between these variables. Now moving on to the next part, which is the random forest model. From the random forest model, we can see that this is also determining the importance of the variable at predicting the total emission, and we can see that oil, coal, cement, and gas, as well as per capita, have quite similar scoring, and they are quite important in predicting the total CO2 emissions, whereas flaring is not that important. So moving also for our root mean square error for our random forest model is 18.03354, which is the lowest out of all of the three models. And we can see from this that from the analysis of the root mean square error that our random forest model is the best model out of all to predict our total CO2 emission. And also that from, as you know about our alternative hypothesis that we predicted before, that one or more than one fossil fuels actually had an impact in predicting the total CO2 emission, we can now accept our alternative hypothesis and we reject our null hypothesis, which means that more than one fossil fuel has a higher contribution to the CO2 emission than the others, as seen by our models as well. And we can also predict that increase in fossil fuel emission can also create increase in total emission, as you can see from the linear model, which shows a positive relationship and a significant relationship between all of the variables. Now moving on. From our analysis from the two models and the feature importance that we saw, we see that the gradient boosting model defines certain elements, certain factors as the most important, while random forest model also determines certain factors as the most important. And you can see that for both of them, oil is the most important predictor, as well as the gas comes at fourth. But as for coal, is also an important predictor. So we can say that there is a general trend that is happening over here, that oil, coal, and gas, when they increase, then the total emission also increases, and they have a significant effect with the total emissions as well. Now moving on to the limitations of our study. As you can see, our data is very complex. We have a time series data, which includes different countries' CO2 emissions, total CO2 emissions, as well as other factors in different times. So it is quite hard to predict our data. We have to do a lot of data cleaning for us to come to a result. Another factor is the presence of null values. As you can see for the other table, the column others, there was a lot of null values. That is why we could not take the table at all. This means, and this is also riddled within our data set, that there is a lot of null values present, and such that some factors may have been removed, which might have changed the analysis, because we had to limit our feature selection. As for the other limitation, there is a possibility of deeper analysis, which could not happen due to time limitations and complexity, because for the deeper analysis, we could also analyze the different CO2 emissions, the trend in CO2 emissions within the different countries as well, which would take a lot of time. Can you close the window? Oh, sorry. Yeah. Oh, sorry. As for, next slide, please. And for the conclusions and the business suggestion, we can see that, as you can see before, coal, oil, and gas are the major contributors to the total CO2 emission. And for the business suggestions, we can suggest different investment opportunities according to, so different businesses can see which countries are most, from our visualization, they can see different years and the trends between the countries and how the CO2 emissions are increasing or decreasing, and they can invest in sustainable development, sustainable business opportunities in these countries so that they can bring down the emissions. Another is competitive advantage. By looking at the sustainable development, the businesses can have a more advantage. They can differentiate themselves from the competitors by prioritizing sustainability and while reducing the CO2 emissions. And it also helps in risk management by looking at the risk and opportunities related to CO2 emissions and conducting their business according to that. That is it for, can you move on to the next slide? This is it for our presentation. I hope you liked it. Thank you for listening.